Once again, welcome to our review meeting. Today we focus on the 1.1.15 release. We have 6 topics. Safik will start with a topic about dropping the TokenInvalidator controller and the webhook that we introduced to improve security a couple of years ago. Then we have Luca with giving us an update about the latest features in the namespaced cloud profile API. Ismail will talk about replacing TopologyAwareHints with a new service traffic distribution. That's actually a topic that we covered in the last hackathon, which now made it to the master branch. Then we have Johannes with better CoreDNS configurability, Oliver with dropping the HPA for the gardener-apiserver deployment, and finally Hendrik with a configurable GOAWAY Chance For requests to the gardener-apiserver. Okay, then Shafiq, please get started with the first topic.
Yeah, thanks, Rafael. Let me share my screen. Okay, so yeah, hello everyone. Today I'm going to present this PR, which is about dropping token invalidated controller in webhook from GRM, and also another webhook, which is for topologies for constraints in certain conditions. Yeah. So first, let's take a look at the token invalidated controller. So so this was added few years back. When Kubernetes used to generate a token, service account token secret for every service account. And later, when they moved to the service account token volume projection, the static token was not actually used, but there was no way to disable it or like stop the generation. So what we did was we introduced a new controller and webhook. So if this auto mount service account token was set to false, this webhook and the controller together used to invalidate this token in the secret. So any attempt to regenerate the token or create a new such secret will again make the webhook invalidated. So this was added few years back. This is present in the doc and everything. But later, now Kubernetes introduced some feature which was stopping this auto generation and a feature kit which was called legacy service account token no auto generation. Yeah, big name. And in 1.27, it was locked to default, which with the value true. Then, yeah, we no longer need this controller and webhook since Gartner's drop support for shoots less than 1.27 with the last release that was 1.114. So we dropped these two from the Gartner Resource Manager. And coming to the next one, this pod topology spread constraint webhook. So this was also added some time back uh, due to an issue with the rolling update. So if we see the pod topology spread constraint in the pod, you can see that there are some label selectors which is used to match the pods by the scheduler during the spread. So what used to happen was in this label selector, there is no unique label and key. So during a rolling update, when a new pod gets created, scheduler tries to look at these topologies per constraints, but these labels are same across old pods and new pods. So these new pods are scheduled as per current uh, current number of old pods and whatever. But then later, when the old pods gets terminated, the maximum skew is violated. And sometimes a lot of pods end up in node one, then no pods in some other node, and so on. So what Gardner did as a workaround at that time was we selected this unique label key, which has a value which differs between new and old revisions of a deployment. So when the deployment new replica set is created, it will have a different template hash so that scheduler will see only these particular pods while spreading the macros nodes. So let's see one of the pods. So I'm currently in Gardener version 1.114. And if I take a look at the deployment and the topologies per constraints, it has all these label and max queue is 1. And yeah, and then later, if I take a look at this pod, for example, we can see that the webhook has added the port template hash, which is unique to every replica set. Then let me go to the new release and try to run Gardener, and let's go back. So now, 1 second. Yeah. So now what Kubernetes did was they introduced this match label keys in port topology spreads feature kit, and the feature, which is as of 1.27, is in beta and defaulted to true. So what it used to do was, what it does is like basically what we used to do with the webhook. So if a unique label is present in this match label key during scheduling, it used to look up this particular value for this key from the port label and also add it to the label selector and yeah, do accordingly. So basically, it's same as adding this label to the match labels, but and if we wait for it, it's to be finished. Something, a little bit of time. Yeah, at the time I can also. So currently, what we chose to do was since this is beta and log to true, in our seats we have disabled this webhook because all our seats are above 127. And we don't disable this feature kit at all. But it could so happen that some users can still disable this feature kit explicitly in QAP server and Kube controller manager. In that uh, condition, yeah, we still need this webhook to be run. So now we enable it only for those shoots which the Kubernetes feature kits are disabled explicitly by the user. I don't think many people will choose to do that, but yeah, if somebody does it, then now let me try to reconcile the shoot in the new version. Yeah, the seed is not ready. That's why shoot is not okay. Yeah, seed is ready now. Should take few more seconds. Now. Okay. So now the shoot has reached 40%, which means QAP server is already deployed. And we can see that this match label keys are now present in the deployment. And if we take a look at the pod itself for the QAP server, it should be the new replica, and we can see that match label keys are present, but the pod template hash is not present in match labels anymore. And this is also forbidden, like it should not be present. These keys should not be present in both label selector and match label keys. So it's done accordingly, and yeah, scheduler should take care when it tries to schedule new pods. So yeah, so this is mostly like cleanup part of our bigger issue to drop support for Kubernetes less than 1.26. So yeah, that's pretty much it. So back to the field.
Thanks, Shafiq, for cleaning up. Any feedback to the topics? Nope. All right. Then next one would be Luca with the latest namespaced cloud profile features.
Yeah, thank you. So, there are two new features in the namespace cloud profile API with the release 115. The first one is that the ability to override the update strategy for a machine image has been added. So to go directly into practice, let's assume we have a cloud profile that defines a machine image, local in this case, and it has an update strategy major set. If I want to have in my project that the machine image is only updated to, let's assume, minor updates, I can create a namespace cloud profile, reference cloud profile, as we've seen before, and define for my machine image local a different update strategy now, which has not been possible before. So if I apply this, then we can see that the namespace cloud profile status, which renders the merged cloud profile spec, now exposes the overridden update strategy minor here and not the major one anymore. So that can be helpful in some cases where project owners want to explicitly override that for their shoots. And the second improvement or update is basically a analog implementation of the maximum node count per shoot from Tim Ebert here in 113. So the implementation is very analog to this. The option has now also been implemented for namespace cloud profiles to set a maximum node count. So if we again go here in our namespace cloud profile, we now also have here a limits parameter where we can set maximum nodes for our shoots so that the shoot is not scaled above that total number of nodes.
Right.
If we apply that.
Wegen gestern Abend. Das war das, was ich meinte. Hat mir gerade kostet.
Thank you. So we can see it's rendered in here. If I go ahead and have a different limit set in the parent cloud profile, we will see that the rendered value is always the lower one of the two. So I can only decrease the total number, but not increase it above the cloud profile value. And also, just like with the cloud profiles, decreasing the value again itself is neither supported in cloud profiles nor namespace cloud profiles. So it would need to be removed and added with a lower value again. And of course, also the validation to not go over configured worker pool limits is implemented just like with the cloud profiles.
Can you elaborate a bit why we took that measure, like to always choose the lower one of the two?
It's assumed that a defined parent value is there by a specific reason. So by infrastructure constraints, and we therefore defined that an overridden value can only be lower for now. I mean, if there
I think
yeah.
we need to change this. I mean, with pretty much all hyperscaler limits, we already found out that they are technically, in most cases, not really hard limits. But if you pressure them enough, they will say, oh, well, for this one account of yours, we will increase that limit. Okay. And I think for these special occasions, we actually need the feature for people to have a higher value in their namespace cloud profile than in the global one.
Of course, we can discuss about that, and if it makes sense, also correct this here. I mean, else it's also possible to have a cloud profile without that limit and just set it in the namespace cloud profile. But of course, if there's demand, I guess we're open to discuss this. again further.
Yep, let's do this. Okay.
I'd like to add that one of the motivations behind adding the limit in the first place was for operators to define how big shoots can get in certain supported environments. So basically saying how much nodes are supported by the Gardener operator per shoot cluster. So I think this still holds true for this story, the case that you mentioned, Marco, that the operators would like to say, I don't support shoots with more than, I don't know, 1,000 nodes.
Yeah, absolutely. There's different reasons for setting different boundaries. One example for a much lower limit is that Azure route tables only support like 400 entries. And if you are not using overlay networking, that means you're basically limited to 400 shoots, to 400 nodes on Azure, right? And as I said, those limits are possible to be discussed with the hyperscalers. So there may be accounts where you have a higher limit than 400, although like mere mortals only have 400. So, and for these cases, we would need the feature to like have people enter a higher limit. And I think what you're saying still holds true, right? If you're saying, do not increase this value or you like void your warranty, then okay, that's also fine. I think Gardener has a number of switches where we basically say to stakeholders, if you tamper with those things, you're on your own. Yeah. If you, I don't know, set cube reserve to a ridiculous value, that's your thing. You can do it. We don't prevent you from doing it. Or
I guess it's
whatever.
Yeah, it's a totally valid argument, as this is probably rather an intermediate feature where users setting this value should be certain about what they are changing and what implications it has.
Yeah, okay, cool. Understood the use case now. We should discuss it further in an issue probably, yes.
Yeah, but thank you for the discussion, Marco and Tim. If there are no further questions, Raphael, please hand over.
Yeah, thanks, Luca. Thanks for the feedback. Then let's continue with Ismail with replacing the TopologyAwareHints.
Yep, I hope you can see my screen. I prepared a few slides because it wouldn't be me if I don't prepare a few slides. I will talk briefly about this PR that did in this 100. Basically, we use service traffic distribution feature of Kubernetes when Kubernetes version is higher than 31 in favor of the TopologyAwareHints feature. Okay, I prepared a few slides with a recap explaining what's the motivation of the feature and what was the initial implementation back then that we did, just to give context what we changed now with the this. Okay, so very fast and very briefly, with the HA, to be able to provide highly available shoot clusters with failure tolerance of type zone, we have to support multi-zone seed clusters, and having such multi-zone seed clusters has the following two challenges with regards to the cross-zone probabilities, cross-zone network traffic. The first challenge is that this traffic is being charged by the cloud providers, and it's not very cheap. And the second challenge is that it comes with higher latency compared to the traffic that stays within the same zone. Okay, that were yeah, these were the two reasons why we invested into this topic as part of the HA story several years ago. Okay, this is how the service traffic and the traffic routing looks like without TopologyAware routing. Here in the diagram, you have backend pods spread on three availability zones. We have one replica in each zone, and we have client, which is available only in one of the zones. So by default, with kubeproxy running in iptables mode, the traffic is being distributed randomly. This means that it is more likely the traffic to reach an endpoint in the other zone rather than to stay within the same zone. And the target picture that we want with the feature is that when possible, when there is available replica within the same zone, available endpoints, then route to this endpoint. If there is no such available endpoint, then go back to default strategy of kubeproxy and route randomly to any available endpoint within the cluster. Yeah, just a brief note here. You might share that, or you might think that this is not safe in all of the cases. Yes, I agree. But in our use cases, the clients are well known, or in the use cases where we apply TopologyAware routing, the clients are well known, and the server is well known. We use spot topology spread constraints to spread the clients and the servers usually across the topology. Right, in this case, the topology zone. We also use VPA to accommodate the load increase and so on. Yeah, just wanted to briefly mention about it. Okay, so far we used the Kubernetes feature called TopologyAwareHints to implement TopologyAware routing on our side, but it has several issues. This feature. The first one is that it's conceptually based on a CPU balance heuristic. The kube controller manager is counting the available CPU cores within a zone, and it applies, or it makes the service topology aware only when it can proportionally distribute the available endpoints of a service across to the CPU, which is available within the zones. For example, if you have 3 zones, one of the zones has twice more CPU as the other zones. Kube controller manager has to make sure that this zone has twice more available endpoints compared to the other 2 zones. Yeah, as you can think, this does not work well in our use case, where the clients and the servers are well known, and like the load to our backends does not depend on the available CPU within a zone. Yeah, I think that's the main drawback with the feature. It's not deterministic because of this heuristic, which is also a safeguard mechanism according to them, to the Kubernetes folks. Yeah, it basically removes fallbacks to the default kubeproxy behavior when it cannot ensure its CPU balance heuristic. And yeah, you could also imagine that in the real environment, you run cluster-out-scaler, the load is increasing, the cluster-out-scaler decides to scale up or scale down a node within a zone, and the CPU distribution across the zones changes, and in one moment you have hints, you have TopologyAware routing, and in the next moment you don't have them. And with this feature, there is no option to enforce the zone level TopologyAware routing mechanism. Yeah, I think years ago I reported all these findings in this upstream issue, and back then, to work around this issues on our side, we implemented a webhook in GRM that is mutating endpoint slices. And basically, we were always setting the zone of the endpoint in the endpoint slice as a hint within the same resource, within the endpoint slice. And in this way, we were ensuring the use case that we wanted. Okay, luckily, the feedback that we provided in this issue and in the SIG networking rounds resulted in this feature called service traffic distribution. Yeah, this feature allows expressing preferences on how traffic should be routed for service endpoints. Briefly, it is a field in the service spec which accepts a value of type enum with different strategies. Right now, the only supported strategy I'm aware of and I see in the documentation is the prefer quote strategy. And this strategy actually does what we want and allows us to route traffic to the service endpoints in TopologyAware and predictable manner. A few more words about the strategy itself. Yeah, as I said, I think in earlier slide I said that it does exactly what we want. If there is a available endpoint within the same zone, route traffic to this endpoint. If no, fall back to any available endpoint within the cluster. Yeah, it's simpler than the TopologyAwareHints. There is no CPU balance heuristic and safeguard mechanism.
Just a
Okay.
very quick time check. I think we should have at most 5 more minutes for the topic because we have 3 more in the pipeline. Hope that works out.
Sure. Okay, I'll skip then the demo. Just a few more slides then. Do you mean that I'm overtime? Or...
Not yet, but you're reaching your official
okay.
10 minutes. So let's give it 5 more minutes. That's fine. But yeah, as said, there are 3 more topics that we need to come.
I'll skip the demo. Okay. Okay, how you make a service TopologyAware in Kubernetes less than 1.31. Okay, so the service traffic distribution feature is a relatively new one. It is enabled by default and beta since Kubernetes 1.31. And that's why in the first slide I said that we use this feature only when the runtime Kubernetes version is higher than 1.31. Okay, so for when the runtime Kubernetes version is less than 1.31, we use the well-known TopologyAwareHints. How you enable TopologyAwareHints? It is with this annotation: topology mode equals auto, and we also in Gardener require developers or component owners to set this label that will be matched by the GRM webhook for endpoint slices that I also talked about. Okay, when the runtime Kubernetes version is 1.31, exactly equals 1.31, this is the new field, the service traffic distribution. It is now no longer annotation, it's part of the spec, and prefer quotes is the strategy that we use. Here, we also decided to keep the webhook, the GRM webhook, and the label on the service resource for 1.31 for migration purposes, because yeah, as we also considered this during the hackathon, for example, when you migrate or when you upgrade a seed cluster from Kubernetes 1.30 to 31, there can be a brief period during this migration where the services in the shoot control planes are not topology aware. Yeah, so long story short, for 1.31, we keep the label and the GRM webhook active just to cover some corner case in the migration and the upgrade of the runtime cluster. Okay, and finally, for when the Kubernetes version is higher than 1.32, it's only required this service spec field to be set. Okay, that's all from my side. If we have time for questions, oops, if there are any questions, I'm happy to answer. If not, I'm handing over to Rafael.
Yeah, thanks, Ismail. Is there any feedback or any question before we continue? Nope. All right. Then Johannes would be the next one with the better CoreDNS configurability.
Okay, I hope you can see my screen and hear me. I take that as yes. So I'm talking about this pull request here. It's not done by me, so it's this pull request and also the whole topic was brought up by Fabian from Plus Server, so credits go to him. What are we talking about? We are talking about making CoreDNS more configurable than we had it before. So if we look at the custom CoreDNS configuration, you might know that we have implemented quite some time ago an option to have a custom config map that they call that cluster owners can put some content in to have their own CoreDNS servers or for individual zones, different servers, or add some configuration options to CoreDNS. Now, as the topic already mentioned, we want to have it more configurable, so we want to see what actually changed. So we have here, I have a small demo, 2 local setups, both remote local setups. On the left side, we have version 1.1.15, and on the right side, we have 1.1.4. We try to do the same thing. We have both a shoot cluster. We want to configure something. And because, our default configuration just log errors. So if there is an error in a DNS query, we want to improve our logging. So basically, we just say log, meaning that we set the logging level to info. We want to forward to a different DNS server. I'm not happy with my standard DNS server. I want a privacy DNS server here in Europe, though I go to Quad9 as DNS server. And I also say I want to reload my DNS config faster. So what I do, that was prepared. I just have some value with .override, and then it takes place and will be reloaded also in my config. So I just added my custom config here in the 1.1.4 release. Eventually, I will see here that the reload is complete. I can do it in parallel also for my 1.1.5 release. I also removed it so the override actually takes effect. And I also check the logs. So on the right side, you see basically the logs of my 2 CoreDNS bots. And now we see already that the first of the 2 pods has reloaded the configuration. The second one hasn't. Our default reload time is 30 seconds, and then there is an additional time because kubelet needs to update the config map that is mapped into the CoreDNS. So now on our old release, we see we have reloaded our config. We didn't see any errors. Everything should be fine. So what I can now do inside of one of the pods, one of the black box exporter pods, I will just do an NS lookup for Gardener Cloud. And well, what I actually want to see is that I see these lookups somewhat ending up in one of our pods. Unfortunately, we don't see anything. So basically, my nice change didn't really work on the old version, just as expected. Now, meanwhile, in the new release here on the left side, the reloading also took place, and we already see that there is some info message going out. And if I now on the new release basically do the NS lookup, I also see here these ones are actually the Gardener Cloud lookup requests. So meaning that I really changed the log level, which I couldn't do in the old release. I can also, if you don't believe me, I can do it with another domain, just resolving Kubernetes IO. Now I hit a different endpoint, and I see Kubernetes IO is also resolved, and I see the request, even though they are not error requests, but info requests. Now, what actually happened and why did we change something? If you look basically in the documentation, we more or less provided here also an example how our configuration more or less looks. What we had before was this import, which is providing the custom configuration, was at the bottom of the CoreDNS configuration, meaning you could provide all kinds of configuration options, but depending on the actual plugin, the configuration came after the original configuration. So for example, what we configured here, or what I configured in my example, was the log plugin and the forward plugin, for example. And previously, the import was at the bottom, meaning I first configured for all domains, meaning the dot here, that we only logged error. And then I could afterwards try to override that with for all domains log info. But since this specification already matches for the log plugin, we never saw the info messages on the old releases. So in the past, you could not override the log specification, for example. The same held true for the forward plugin, where we also, where we had a specification to use the infrastructure DNS server, and you could not override it because effectively the plugin was already configured for all domains to go to the to the default infrastructure provided DNS server. Now we changed that for some, because as you see, we have put it in the middle. We have some plugins where we assume that it doesn't make sense to override them. For example, the Kubernetes plugin, we assume you want to reach the use your Kube API server to resolve services and the like, and not use in your data plane a different API server. You can still do that with different server records, but your default should be your API server. Same holds true, for example, for metrics. We provide scrape configs, and changing the metrics port would simply invalidate the scrape config, so that doesn't really make a lot of sense. But changing the log level could make sense. It might increase the load of the server. It might increase the it will considerably increase the load of the logging system, because there are a lot of DNS queries most likely going on, but you can do it. And you can also do changes to the forward plugin, so your upstream DNS server, the cache, the reload timeout, or even if you change the load balancing, you can add some weights for certain IPs, so that if you have multiple results for one DNS name, that some IPs are more preferred than others. So that's basically the topic. So now CoreDNS is more configurable than ever before. Hopefully that helps. And thanks again to Fabian for providing the feature.
Cool. Thanks for presenting this. Thanks, Fabian. Any questions, any feedback? Nope. Okay, then thank you, Johannes. And over to Oliver for dropping the HPA for the Gardener API server.
Yes. Hey, good morning. Today I can present another topic. It's one of the small tuning measurements for the Gardener API server. the Cube API servers we did recently. And this one is a pretty simple one. It's about removing the horizontal pod autoscaler from Gardener API server. So why do we do this? As you might know, when you access a Gardener object, you don't access the Gardener API server directly, but you access it via the aggregation layer of the Cube API servers. And those Cube API servers usually create a single HTTP2 connection to the Gardener API server. And this can have several implications when horizontal pod autoscaling comes into place. So every time when there are more Gardener API servers than Cube API servers, you don't see any requests on the, let's say, access Gardener API servers, because you just have the number of HTTP2 connections is exactly the number of Cube API servers. And this leads to a couple of things. Basically, it's kind of waste because we reserve capacities for Gardener API servers and maybe start new nodes for them. And those API servers do not handle any requests. And the second implication is that the VPA resource calculation is inaccurate because you have some idle Gardener API servers and some very busy API servers, and you don't have, and you will receive some kind of average between those, but not the concrete load. Yeah. Okay, and we found this as a kind of common pattern here in some of our landscapes. So usually we have more loads on the Gardener API server than on Cube API server. So it's basically like we have one CPU per Cube API server, but 6 for the Gardener API servers. So usually it's quite common that horizontal pod autoscaler would increase the number of Gardener API servers, but keep the number of Cube API servers at the default level. Okay, yeah, and finally, the change is, as I said, pretty simple. We remove HPA for the Gardener API server, and now it's set to a fixed number of replicas, and those are 3 in the HA case and 2 in the non-HA case. Okay, we discussed other measurements like disabling HTTP2 in the Gardener API server to force the Cube API server to create more connections. But we were not really able to see the consequences, or to decide whether it has only good consequences or whether there are also negative effects of such kind of a change. And so we decided to do the easy, simple solution first. And if we hit limits in the future, we can investigate for other measurements. Okay, so I also prepared a small demo. Oh, at the moment, Cube API servers are autoscaling. Let's see if it's affecting the demo. But right now you can see I created some load for the Gardener API servers by some load generator. And at the moment, it's like perfectly balanced between the Gardener API servers. I'm not able to do the autoscaling by HPA because I cannot generate such a high load on the on my laptop that HorizontalPodAutoscaler is kicking in because it was configured as I think at 6 CPUs, and I'm not able to do this on my machine. So I'm just playing HPA at the moment, so that you see that this autoscaling for the Gardener API servers not working properly, at least the horizontal pod autoscaling. So I'm HPA, and because of the high load, I'm increasing the numbers of replicas to 4, and we see a new pod coming up for the Gardener API server here, and it has some initial load, but after a couple of seconds, the load is reduced, and basically this does not change over the time. It's because of this number of 3 Cube API server replicas. We can also increase it further, and we won't see any difference. Okay, basically this you see here also a kind of hint for the next demo Hendrik is is going to present in a second, because you've seen that the Cube API servers has been rolling. So now the load on the Gardener API server is not perfectly balanced anymore. But Hendrik will show a measurement for this later. But what I wanted to show is that when you increase the number of Gardener API servers, they don't get any load when this happens. And you can even increase, you can even scale up the virtual Cube API server, and this you have to be lucky that this API server hits a Gardener API server which does not serve any requests, because it has to be in the same zone and whatsoever. So it's really not working properly. I watched landscapes for a couple of days, and it has been always the case that only 3 Gardener API servers has been busy, and the other ones were idling. Yeah. Okay. That's it.
Thank you, Oliver. Any questions so far before we continue with the natural follow-up topic? Okay, then Hendrik, please go ahead with the GOAWAY Chance.
All right, thanks a lot. So let me quickly set up the sharing. All right, so essentially the problem domain can be expanded, and it's essentially based on the following pattern that you see on my screen. We have the virtual Garden Cube API server receiving some load. It's forwarding to the Gardener API server for anything that's related to the Gardener API groups. And then you have 2 out of 3 Gardener API server pods basically idling. They're super busy on their readiness probe, but that's pretty much it. And the other replica gets all the load. It's basically hammered with all the requests that are incoming for the Gardener API group. And we've seen that in our landscapes every now and then, happens sporadically. And now we sit down, try to analyze, figure out why it's happening and what would be the kind of solution to it. So let me, before jumping into more details, just quickly apply the solution, which would be configuring the GOAWAY chance on the Gardener API server. So again, it's a local garden. Here we go. So just taking a very large value in terms of fractions to have a visible effect fairly soon. So let me just apply that. And while it's rolling out, let me just explain what has been implemented in this PR and how it is going to affect our landscapes or any landscape when you configure it. So the kind of problem could be summed up in the following graphic. So we have the Cube API server connecting to the Gardener API server on a fairly stable, long-living HTTP2 connection. We had that already in this meeting. We have this set up for multiple replicas, potentially also multiple zones. And when you do a rolling update, everything works nicely and fine, because what happens is you have a max search of 100% and max unavailable of 0, which means there will be a new replica in each zone or each failure domain that is configured that the respective Cube API server can connect to when the other one is shutting down finally. Now, there's one case where this assumption is broken, and that is when we talk about evictions. So either it's node draining or it's about VPA evictions. Then you have a case that the very first pod is evicted, and then the Cube API server reconnects to one of the existing Gardener API servers in a different zone because the new one is not yet running and comes up and does literally nothing. Then the next one gets evicted, so this one can reconnect. This one potentially also connects to the new one. And the same happens for the last. So these reconnections, they're then happening on the regular IP tables-based round robin. So with the statistic probability of the remaining replicas, you end up on one of the two running Gardener API servers. And in the worst case, you have a scenario that I just had where 2 out of 3 pods are basically idle. They're just not getting any requests, and the third one is getting hammered by all the incoming requests. Now, the solution, the Cube API server and Gardener API server, or generally a Kubernetes API server, allows to configure a GOAWAY chance. And the PR that Raphael implemented, thanks to you, basically exposes that configuration flag that will allow us to send a GOAWAY frame every now and then, and therefore reset this connection. We'll force the Virtual Gardens Cube API server to re-establish a new TCP connection to connect to the Gardener API server within its zone. And then, yeah, the only question probably is what's a meaningful value. So I've tried to calculate it. Well, yeah, okay, just quickly running over it. I would say you want to have like the requests per minute that you have on all the Gardener API servers in total, and then you can figure out what is a meaningful GOAWAY value, like how many GOAWAYs per minute or how many minutes should a GOAWAY take. The requests can be calculated by this easy to remember Prometheus query. You can fetch it from the Gardens Prometheus and GOAWAY, for example, every 5 minutes or something like that. And then we end up with a probability that we can go ahead and configure. Choosing something like 5 minutes would also imply that if we have a perfect distribution across all Gardener API servers, each Gardener API server terminates its connection to the Virtual Gardens Cube API server every 15 minutes. And if everything is pointing to a single copy, that then after 5 minutes, it's very likely that at least one of the other Cube API servers, Gardener API servers, is getting some traffic. If time permits, I can also run a very brief demo on that. So right now, we still put load on Cube API servers, right now it's equally distributed. That's the effect of the rolling update. So every Cube API server connects to the virtual to the Gardener API server in its own. If we now go ahead and simply terminate 2 out of 3, like this one and this one, and which one? API server. Wait, typo. Right. Then now those 2 are terminating, they're shutting down. These 2 are not yet up and running, so all the connection go to this single replica. And if we watch the top command, then the new pods will eventually show up. They consume a little bit of CPU and memory when they do their startup. In the meantime, this one is getting all the requests, but with that very small fraction that was configured, it will redistribute after a short amount of time. And that, in the end, solves the problem that otherwise you would have to implement a regular cron job or something like that that does a kubectl rollout restart for the deployment. So essentially, a tuning mechanism that is highly specific to the way any landscape is used, to the amount of requests that a landscape receives, and probably a value that you need to revisit every now and then when the pattern on the landscape changes. It's, at least from my perspective, a quite powerful tool to keep things fairly stable, even though autoscaling happens in the background. Right, that's it. We're still on time. And thanks to Raphael for implementing it.
Awesome. Thanks, Andre. Any questions or feedback?
Hi, this is actually a general problem with microservice to microservice communication, which involves long-running connections, right? So it's not just restricted to Cube API server and Garden API server. It would affect any kind of microservice to microservice communication on Kubernetes, where the HPA launches new pods and you have long-running connections. The traffic won't go to the new pods.
Yep, that's true. At least when we ran this analysis, we found this to be like the most problematic on the Gardener API server, because it's simply one of the, let's say, elements in any landscape that receives quite a lot of traffic. So it was most visible there. And the effects could also, for example, lead to a situation where you run out of CPU on a single node. And then the system overall gets throttled and you have a service degradation.
At least there should be some sort of event so that the microservice making the request knows that, you know, there are new recipients, and it should gracefully terminate connections and open them again, right? Something like that would have been ideal. So, I mean, in the Kubernetes architecture, not what you're, I mean, this is mostly a hack to fix that issue, I would say.
Hard to judge, I would say. I mean, in the end, it's a consequence or a follow-up of those of the protocol stack, where you have these long-running HTTP connections that reuse a single TCP connections. So using measurements or capabilities of that protocol stack to kind of remediate the situation, I think it sounds not too bad to me, at least. But sure, I mean, if there's a good way how Kubernetes could make endpoints aware of such events, well, would be nice.
I think the point is that you would need some form of connection pooling, right? And that's not what usual applications implement by default. Some database drivers probably implement such things, or similar libraries, but the basic applications usually don't implement it, but it could be added to them via some form of service mesh, right? So Envoy sidecars, etc., etc. And then you would do some connection pooling and circuit breaking and so on and so forth. But for usual applications that just open a single connection, TLS, and then do HTTP multiplexing, the GOAWAY chains is a perfectly fine tool, I would say.
Okay, I thought HTTP2 had connection pooling by default, so anybody who uses HTTP2 would run into this issue anyways. So, but fine, I think.
Well, there's only a single TLS connection, and then you do multiplexing of HTTP requests over it, right? So there's no pooling or anything. There's this concept of streams in HTTP2, but that's not comparable to connection pooling, I would say. But yeah, details.
Right. Let's maybe stop here because we are already 2 minutes over time. But yeah, thanks for the discussion and the feedback. That's cool. And yeah, thanks everybody for joining. Thanks to all presenters. And then we meet again in 2 weeks. Have a nice time. Bye-bye.
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 See you.
Bye.
Bye-bye.
Thanks. Bye.